Hi everyone. I came upon this very interesting video from Bare Metal Studio where someone who seems to have some programming experience but maybe not with too many programming languages is trying to learn something different, something new, and that is Zig. And I got fascinated by the great questions that were posed and how much actually a Hello World program from Zig has concepts that are worth explaining. And I wanted to try to do that today. So let's start from the beginning. The import statement in Zig looks like this. In C, of course, it looks something like this. Um, So why did Zig choose a syntax like this? So first, you need to give a name to every import. And then you need to use the imported module through that name. Why is that important? Well, if in C you have also some third-party library that you want to import, there is nothing preventing this library from also exposing a function named printf, and then you will get a compile error that won't be easy to solve because two of the libraries you want to use are exposing the function with the same name. But since Zig forces you to give the name to your imports, it allows you to give a specific name to each one in your own program, and that way prevent name collisions. Next part, here is this import function with this strange symbol. So what is that about? So that is a compiler built-in function. Now, why a compiler needs built-in functions? Well, one example why it might need some is the following. So let's look at a statement like this. So here we have a simple addition, and the CPU actually has an add operation, and this addition in higher level language written with a plus sign will be converted to add instruction on our processors. But processors have many different instructions that you can't easily represent with symbols you can easily type on your keyboard. So they can be exposed as functions. That is one example why compiler needs built-in functions. And here we can see, for example, one such function like pop count. It counts the number of bits set in an integer. This is the instruction that our processors have, and Zig is exposing that functionality of your processors through a function like, through a built-in function. And actually, C programming language has something similar. It calls it intrinsic functions. Here are some examples from C. It also has pop count. And you can also see that they are also written in a strange way with underscore at the start. So why is that? Well, they want to avoid namespace collisions with your own functions. And that is one reason why Zig chose to have this @ symbol at the start of its built-in functions, because it doesn't want its built-in functions to collide with your symbols. Also, they want it clear because Zig's philosophy is that everything has to be explicit. So they want it clear when you call a built-in function that you are calling your built-in functions. They want someone who reads the code to be clear about that. So I said having CPU functionalities exposed is one reason for built-in functions. Another example is size of, to get the size of some type. And of course, another example is the import function to import a module. So many things can be a built-in function, and that is the reason why Zig chose to name them in such a way. Is there anything else about importing? There is one more thing that I want to cover at the end. But let's first go through the rest of the file. So the main function definition needs to be marked as public. In C, functions are public by default in a way. They need to be, so your compilation unit that defines the main function needs to expose the main symbol. So when it is linked with C runtime, that C runtime can call into your main actually, because that is how it works. And since Zeek functions are private by default, you need to mark them with pub to make them public. And similar, Zeek has its own runtime that will call this main function, so it needs to be public. Now in C, main function can receive no arguments, and that is also valid in Zeek. But in C it can also receive an array of strings, let's say, which represent command line arguments that are passed to your program. But in Zeek, they realized that command line arguments are not the only input that you are passing to your program. For example, your program also receives all the environment variables as its input in a way. And in C, you have to know to call special functions to get those variables. But here they wanted to use the init parameter of main function to have a convenient way to pass even that information to you. Now, besides this std process init, you can also pass, I think, int minimal. So here you only have command line arguments and environment variables. But you can also pass init, and now it has that minimal. It has environment variables exposed as a hash map. And it also has a few more things. So in Zeek, they want, as I said, everything to be explicit. And they also want that every function that needs to allocate memory needs to receive some allocator as a parameter. They want that so that you can control how allocations are done top down, from the start of your program down into libraries. They don't want to have a global allocator like C, so that every library can call malloc how it wants. They want to provide this control to the top level, so that when you are writing your program, you can always control how allocations are done. So the idea is that you define your allocators in the main, and then you pass them down into different functions of different modules, and they use the allocator that you provided. But again, it's convenient to already also have a predefined allocator that even your main function will receive, that then you can use further. And that is what these two fields are. So you get them as a convenience, so you don't have to define allocator yourself. And you also need to have, in recent versions of Zeek, one more interface that is called I/O, that provides all the functions that the operating system exposes, basically, that are used for like communicating, reading files, communicating with sockets, waiting on timers, stuff like that, so that you can also decide on what kind of implementation of I/O do you want. So do you want an I/O implementation that does everything synchronously, that whenever you say read, it goes into operating system, waits for it to finish, and then continues your program? Or you want a threaded implementation that will start different threads for different operations automatically, and similar. So this again allows you to define your implementation of I/O at the top level, and then pass it down to all the functions that need it, so they can work the way you want them to work from the top down. If you want them to work as multi-threaded, you can pass a multi-threaded implementation. If you want it to work single-threaded, you can pass single-threaded. If you want it to work through some coroutines, you can pass a third implementation, and similar. So that is the reason why Zeek has this bit more complicated init parameter. They want to provide you the input to your programs, but also some convenience initial values for these things that are interfaces that are needed throughout your program. Now return type is defined with this exclamation mark. So this means that this function can return nothing or an error. Why do we need to return an error? Well, as we can see, we are using a try here. So what does try mean? That means that this function that you call here and that when we look at its documentation, we can see that it can also return an error or nothing. And what this try does is basically says, try to call this function. If it returns an error, return that error from main as well immediately. If it doesn't return an error, then you can proceed further. So this is why we are returning error here. Now, why does writing to standard output returns an error? Well, because like writing to any other file descriptor, it really can fail. This is why in C, when you call printf, you're writing to standard output by default, and it can fail. But C doesn't give you any mechanism to process that fail, to react to it, to even see it is possible. And this might be bad. I mean, if you're writing a program that writes some output that some other program needs to process, it is important that your program either crashes if writing that output fails, or handles that error some way instead of just silently sort of succeeding without providing valid output. So Zeek didn't want to hide it. As I said, it wants to be explicit, so it made writing to standard output possibly return an error. It also made this verbose thing like this, but when you think about it, it made it very, very clear. You are writing a whole string to standard output using file interface, file kind interface. So in C, you just call printf. Now, you quickly learn what printf does, and so it's clear to you. But if you didn't know anything and you saw such C program for the first time, you might think that printf sends things to your printer. I mean, it's not that clear what it does from the name. So Zeek makes it very explicit and very clear what it does. Now, the video also mentions another way to do printing, which is this. So here, this looks a bit more like printf. Maybe it's simpler. It also takes a template string where some placeholders can be replaced with arguments. That is done by passing a tuple in Zeek. Most of values can be printed directly without any specifiers, and some types like string needs specifiers, format specifiers. Now, this also prints things, but to standard output, and it doesn't return an error. Now, you might think if writing to standard output can fail, then writing to standard error can fail as well, and that is true. So why this function doesn't return an error is because, as its name suggests, it is meant for printing debug stuff like logs and similar. So you don't want your application to crash if you can't log something. So that is why they made this convenient function that you can call for printing things that are not crucial to the actual purpose of your program, actually. And that is why it doesn't return an error. I think that is all. Yeah. So the last thing I wanted to explain around importing is the following. So let's look how we define structures in Zeek. So it looks something like this. Now, what can you put into a structure? Well, of course, you can put fields, like in any other language. Next, you can put like constants. You can also put variables. Now, what does it mean to put a variable in a structure? How is it different from fields? Well, if you know some other languages like C#, you can think of it like this. These fields are like fields in a class or structure in C#. Const is also like a constant there. So it's just a public constant basically that is a part of this namespace. This structure is providing just a namespace for this constant. And in the same way, this structure is providing a namespace for this variable. So it is like a public static variable in C#. And one more thing, yeah, you can define the structure, of course, are functions. So whatever. In Zeek, fields are always public, but other things are private by default, and you can make them public, of course, if you specify pub at start. And of course, nothing prevents you to also define the substructures within the structure. Now, when you look at this, you realize something. In the file scope, just like we have a function here, we have a function in the file scope. There is nothing that prevents us from having global constants and global variables in the file scope as well. These are just namespace to the file and not to some specific structure. And you can have, of course, structures defined in the file scope. So that leaves fields, and Zeek actually allows you to define fields on the file level. So what does that mean? Well, it means that in Zeek, files are actually structures. That is how they decided to treat them. The files themselves are structures, and when you import some module, you're just importing that structure and giving it a name, just like you are giving here a name to this structure. So that is also one interesting idea that Zeek has, and that is useful to understand. You will notice maybe when you import some modules, their first letter will be either lowercase or uppercase. Lowercase letter is a convention that means that you're importing a module that doesn't have state, doesn't have fields. So it is just a namespace for functions and constants, like STD. So it has this structure, which has this structure under it, that has this function under it, similar for debug. But if the name starts with a capital letter, it means that that file actually has fields in file scope. It has state and should be treated just like any other structure. And so you import it with a capital letter, and you usually also give it a name with a capital letter, because that is the convention used in Zeek for type names. Anyway, I hope all of this was useful and interesting. I hope you understand better now why Zeek made some choices that it did. And I hope you had fun. So, happy coding!